Hello everyone, I'm Howard Han from Carnegie Mellon University Human-Computer Interaction Institute. I'm glad to present our paper, Co-Designing Accessible Public Robot, Insights from People with Mobility Disability, Robotic Practitioners, and Their Collaborations. On behalf of my collaborators, frankly Mingzhe, Alesandra Baca Vazquez, Daragh Byrne, Nikolas Martelaro, and Sarah Fox. Recent years have witnessed the emergence of sidewalk robots, which are essentially mobile robots operating on public sidewalks to perform human tasks, and some states in America have also regulated them as pedestrians. However, prior research have indicated that the presence of such robots potentially poses threats to other sidewalk users, including people with mobility disability. There was also a real-world accident that supports those judgments. We were very motivated to understand the relationship between the two stakeholders, especially to think whether we can design more accessible and responsible public sidewalk robots. So to this end, human-robot interaction literature provided design factors and methods for us to discuss and test. In this paper, we asked three research questions. First, how do people with mobility disability perceive the presence of sidewalk robots considering different design factors such as navigation patterns and speeds? With the aforementioned tensions, we approached two roboticists in both industry and academia to understand how they view accessibility in their current workflow. Lastly, we wonder, how might robotic practitioners and people with mobility disability collaborate together to conceptualize and prototype public robots? How might the ideas and conversations in turn inform the current HI practices? To answer these questions, we adopted a three-phase research method. Firstly, we interviewed 15 people with mobility disability and then 8 robotic practitioners to understand their perspectives. Lastly, we paired them in the co-design workshops to see how they actually, work together to challenge the current definition and design of accessible public robots. In the first study, we illustrated robots with different design factors from the prior HR literature by providing explanatory images and videos. This can be a robot in different approaching strategies and in different forms such as height and width. We then asked people with mobility disability on how they perceive the design and encounters with the sidewalk robots. And then we provided different encountering scenarios with interaction modalities. Ask the participants how they would like to interact with the robots in the given situation and how they would like the robot to interact with them. The co-design sessions featured early ideation of public robot design ideas. People with mobility disability would initiate the conversation by sharing their need and imagining a robot to help them. The roboticists then joined the conversation to develop the idea by considering the viability and the technical implementations. We recommend you refer to our paper for a more detailed setup of all the studies and data analysis. Let me first walk you through the perceptions of people with mobility disability on different robot designs. From our findings, we found that there are several design factors and robotic behaviors that lead to potential conflicts and even intensify them. For example, all participants expressed extremely negative opinions towards the idea of robot patrolling in teams, worrying that this could occupy the whole sidewalk, especially the curb cut, for a period of time, and they would be very hesitant to pass the robot team. Aside from worrying about competing space on sidewalk, people with mobility disability also worried whether this robot can recognize their mobility devices such as cans and wheelchairs and dodge it when encountering them. For the purpose of safe interactions, all participants also identified interaction features that contribute to relieving the potential conflicts. For example, one participant advocated that there should be a way, either by voice interaction or physical interaction, to instruct the robot to go off the sidewalk. In this way, they can have the right and have the space to pass. They also want the robot to be more explicit when they are having behavior changes. One idea they shared is that the robot can announce themselves when bypassing the virtual users, so the virtual users can have more time to prepare and respond. Now, let's turn to how roboticists integrate accessibility into their current practices. We found that most of our participants, both in academia and industry, view accessibility as post-issues. That means they focus on the robotic capacities and innovations at first and only address accessibility after accidents arise. Part of the reason is that for startups and even tech giants, fully considering accessibility seems to be very costly and can delay the launch of their products. However, all participants also shared that addressing those accessibility issues always require navigating through both hardware and software compatibilities, and considering the disabled community is also a necessary step for a robot company to be socially responsible and ethical. Thus, the implication is that being aware of the accessibility needs might actually make it easier to address them and have a broader social impact. This motivated us to hold the co-design workshops. The co-design workshops outputted 4 robot prototypes, and I would like to zoom in one of the ideas to share more conversations happened when they navigate to the final designs. In workshop 2, Angie, a power chair user with limited hand dexterity, recalled her experience in grocery store. She sometimes found the human assistant to be unavailable or simply feel awkward to ask for help. Thus, she expressed a desire for assistance in fetching grocery that can be done by robots. Michelle, a roboticist, quickly mapped the components the robot should equip and found the inspiration of existing fetching robot that has a robot arm to guide items on the shelf. However, Edgy commented that the robot's ground would take the entire hallway and make it harder for her to navigate. Thus, she asked whether it is possible to use only one wheel for the robot to navigate. However, this idea is recognized by Michelle as mechanically challenging. But notice this concern. Michelle thought that instead of the robot navigating on its own, it may be able to integrate into some existing infrastructure to not taking extra spaces. They realized that the shopping cart might be possible to work as the ground of the robots. Together, they developed the idea for a robot that sort out things using a perception system, grab the items with a robotic arm, and can be integrated into a shopping cart to navigate. As shown in this case, there were instances when teams need to work through conflicts around robot features desired by the people with mobility disability and technical feasibility of implementing such feature. This disagreement sometimes lead to more accessibility needs and concerns being uncovered. In this grocery robot design, we found that people with mobility disabilities idea centered on the need to independently perform tasks that would otherwise require human assistance. This could also contribute to their own autonomy. Consequently, they expect the robot to be able to provide natural interactions such as understanding their surroundings and requests. Across all 4 workshops, we also found that all the robot designs featured carrying capacity for people with mobility disability to navigate the physical world. To ensure usability, there have always been 2 or more modalities being discussed. This echoes our findings in the interview that current robots might lack multimodality capacity for people with mobility disability. These early conversations address some low-hanging accessibility issues such as interaction usability and managing space sharing. The co-design workshops can also reveal even more opportunities for supporting public robots and designing for the benefits of disabled communities. After their collaborations, both groups shared very positive comments on the idea of having co-design workshops. For roboticists, the inclusion of people with disability made it easier to change, modify, or include new ideas that would improve accessibility, which is also beneficial to improve their products. For people with disability, the process of narrowing down from their imaginations to viable products also helped them to reveal the core value of the robots. We envision our work as a detailed exploration of accessible robots. Looking ahead, we anticipate that the HI and HCI community will develop more accessible and responsible robot interactions, especially as robots continue to integrate into the public spaces. The insights and design opportunities outlined in our paper can serve as a solid foundation for further experiment and development. So, leveraging the success of our co-design workshops, future endeavors could also emphasize community-driven participatory approaches, engaging a broad range of stakeholders into the creation of public robotic technology. Reflecting on the robots within social technical system, we recognize that existing practice and regulatory framework may not sufficiently cover all necessary aspects of accessibility. We ponder critical questions for future robotic developers. What considerations should be made regarding accessibility? And beyond the parameters currently regulated by government, what other factors should be considered for regulation and how might we approach this? At its core, how do we perceive the evolving interplay between public spaces and robots? These are essential inquiries that need thoughtful examinations and future work. To conclude, our research employs qualitative and design methods to explore how people with mobility disability perceive robots of varying designs, how roboticists incorporate accessibility into their workflow, and how these two groups might collaborate for future civic robots. All findings shed light on the challenges of inaccessible designs and offer strategies for improvement. Through both interviews and co-design workshops, we recognize that inclusion is essential for developing robots that truly cater to the needs of people with mobility disability. Additionally, we pointed several promising directions for making both robots and robotic practices more accessible. Thanks for listening to our talk.